Doing a problem today, Advent of Code 2015. This is day 9, all in a single night. And my apologies to you if I'm talking a little bit slow. Feel free to increase the playback speed here. But this problem is pretty straightforward. The vignette says that Santa needs to deliver all of the presents to a collection of cities, and these cities have distances between them, and the goal of the problem is to find the shortest possible path between all of these cities given the distances. So in the case of this input up here and these possible distances, the shortest one would be this right here. Okay, so if we look at the input, you can see I've done this problem before, but if we look at the input, you'll see that there's 1, 2, 3, 4, 5, 6, 7, 8 cities. And you can glean from this input that this is a complete graph, meaning that each city is connected to every other city by a two-way road. And that road is the same distance going to and from the destination and the source. So this is a complete indirect weighted graph. That's very important to know because we can apply some math to this problem to determine the best approach. So for 8 cities, the number of possible paths that Santa can travel in is 8 factorial. And that brings the total number of paths to about 40,000. And that is in brute force. This is in brute forcing range. So I can essentially just generate a list of permutations of the cities, of the list of cities. And for each of those permutations, I can calculate the total distance if Santa took that path, and then keep track of the minimum path, essentially. And that is a perfectly viable solution. Now, I'm going to be doing this problem in Zig, and the challenge there is the standard library does not give me a resource to generate permutations of a list. So I'm going to have to create that resource myself. The standard way of doing this is to use Heap's algorithm. This is not heap sort, this is Heap's algorithm. And this will give me an unordered list of permutations in the most efficient possible way, basically doing strategic swapping. Now we're going to talk about this algorithm in a bit, but it's important to note that this is not the most efficient way to solve this problem because there's 8 cities and I'm doing 40,000 operations, right? So that's n factorial time complexity for the total solution. An optimization you could make if you wanted to is to generate the permutations in lexicographical order. I'm not sure I'm pronouncing that word correctly. You can correct me in the comments if you want, but the advantage of generating everything in lexicographical order is that the first permutation is an inverse, exactly the inverse of the last permutation. The second permutation is the exact inverse of the second to last permutation. And a permutation and its inverse will compute to the exact same distance. And just to give you a visualization, down here, this is lexicographical ordering, and you can see the first permutation is the inverse of the last, the second the inverse of the second to last, third inverse of the third to last, and so on and so forth. So even though this algorithm is slightly less efficient than Heap's algorithm, because you're only going through half of the permutations, the overall solution is actually twice as efficient. So that's one way to optimize it, but it's still n factorial. It's just n factorial divided by 2. If you wanted to solve this problem in the most optimal way possible, the algorithm you'd want to implement is called Held-Karp algorithm. And this changes the problem into a full-blown dynamic programming problem where you're not just keeping track of the distance of the full path, but also of all possible subpaths. You're caching them in some way and then hitting that cache, I imagine. I haven't looked at this too deeply, but you can see that down here there is some pseudocode. So feel free to try this if you feel up to it. But we will be doing heaps algorithm. And I just want to give you a quick intuition into how this one works. So if we look at the picture that's included in the Wikipedia article, you can see that they're performing heaps algorithm on this list A, B, C, and D. And what you'll notice is this D element is stuck in the very last position while all of these other elements are just moving around. This D is stuck. But once the rest of the elements go through all their permutations, the D rotates out for C, and then the same thing happens with C. C stays stuck to this last position while all the other elements are moving around. And then B gets a turn, and then A gets a turn. Now, if we come back to the top here and focus on just this D section, and then just look at the subarray of A, B, and C, in the article it calls it the K-1 subarray, you'll see that the same pattern repeats in the subarray. So C stays stuck in the last position while A and B are swapping. Then B gets a turn to stay stuck at that last position while A and C are swapping. And then A stays stuck in that last position while B and C are swapping. Now, just with that intuition, I bet you could generate the pseudocode on your own. Now, of course, we're not going to do that because the Wikipedia article, if we scroll down enough, you can see the pseudocode is just provided. And in particular, we're going to be doing the iterative version because it seems simpler, and the recursive version has some footguns in case you want to try that. They talk about footguns further down in the article. I'll leave that to your discretion to review, but we're just going to be doing heaps algorithm, referencing pseudocode as needed. So let's just get into it. Okay, what version of Zig am I on here? I think this is same as last time. Okay, let's just get started here. First, we need input. Okay, let's go here. I think we have it, right? I'm gonna try and do this as quickly as possible. And if you feel the need, feel free to increase the playback speed. Okay, so while I am, writing out this boilerplate, I guess I can talk about something that happened to me recently. So I don't know if you guys know about Free Code Camp, but this is an outlet that offers like a online portal where you can do lots of practice problems, and they essentially help to teach people learn to code. And not only do they have this online portal where you can do some practice problems and keep track of your progress, but they also host events, and these events are really cool. A lot of times they have pizza and soda, and the whole point is you show up and you work on your Free Code Camp curriculum together with people. So I decided to attend one of these, and I just wanted to see what the kids were up to these days. And I met this girl there who wasn't working on the Free Code Camp curriculum. She was working on her homework for CompSci. And, she was, doing some Python, and she was learning things like, this is a variable, and this is a string, and this is an integer. Just the first baby steps into a much longer path. And it was super interesting for me to see that because it's been so long. But she also happened to mention some insecurities. And, those insecurities went something like this. I don't know if I belong here. I'm not any good at this. AI can generate this stuff faster than me anyways. What's the point? And, the whole time I was thinking to myself, what do I say here? And what I landed on was, what? She's a youngin'. She needs some reassurance. She needs encouragement. And that's what I decided to give her. But that's not what I wanted to say. What I wanted to do was to validate her feelings. And the reason I did not validate her feelings was because at this time, at this moment in the industry, and perhaps in any industry really, the validation is really scary, and it sounds something like this. You are going to be feeling these feelings for pretty much your entire career. And really, the only thing that you can control is how do you respond to these feelings. Like, just by example, okay, so I work at a fintech company, and I work with some amazing engineers. I mean, these guys are absolute, beasts at what they do. And, I have these feelings too. They're just in the back of my mind because I'm so busy operating that I just don't have the time or the capacity to dwell on it. So I'm just so you guys know what this exclamation point means. This means that the main function could potentially return an error, and you'll see this. You'll see this sort of thing used all throughout the solution. But let's just keep on trucking here. Let's start with the writer. Okay, let's do var buffer. Man, I am really tired. Okay, so we have a buffer here. And then we'll do a var file writer. And we can get this from file.stdout.writer, and then we'll just pass in a reference to a buffer. And then finally, the writer instance is going to be a pointer to the file writer interface. Okay. Yeah, man, there's always bigger fish in the sea. Like it never ends. There's always going to be somebody better. But really, you only have two ways to respond to that reality, right? Your first option is to just fall into despair. Just be like, oh my God, I'm awful. Everything is awful. Nothing will ever work. Or you could do what I prefer to do, which is to let it motivate you. Like if somebody's out there and they're doing amazing work in an amazing way, I mean, let's go, dude. Like I'm down. Like I want to achieve that for myself, So that's, in my opinion, the correct way to respond to that sort of situation. But the feelings won't go away. They'll just move to the back of your mind. And that is, unfortunately, the state of things, unfortunately. So let's see here, and then we can do const reader, and this will be just a reference to the instance. I think we're good. So now alloc, and then finally I'm going to forget to do this, so I might as well do this here. Let's flush the buffer. Yeah. And you know, while I'm on the topic of addressing her concerns in the way that I would have liked to, I want to address AI. So it's been a while now. AI has been around for a while now, and I believe that the industry as a whole is landing on what AI means for engineers. They're landing on, you know, what is actually going on here. How is this going to impact engineers? And I don't think anyone thinks, I mean, 0% of people that I've talked to, at least at my company, think that it's going to replace engineers. I think it's just a tool. And as long as you have that mindset that, hey, this is just a tool, it's meant to make me more efficient, then you can evaluate it, you know, correctly without letting it mess with your sense of self, you know? So, expected, whatever. Let's just see if this builds. Zig build exe sol.zig. Yeah, it builds. Okay, very cool. Yeah, I hope she's doing okay. She seemed like a great kid. So let's now focus more on our situation, which is we have to implement Heap's algorithm. I want to do that first because if that part of it doesn't work, nothing will. And I'm gonna try and put some elbow grease into it because I have a feeling I'm gonna reuse this code. So just bear with me here, guys. And in particular, we want to return a struct. And I'm going to do self at this. Now, Loris Crow wrote an article recently saying that he doesn't like it when people do this, but I'm going to do it anyways because I don't want to type permitter, permitter everywhere. So what are we going to need? Let's think about this. We're going to need a reference to the list, which will be of type T. We're going to need a counter, which is going to be usize. And if you're following along with the Wikipedia article, this is C. This is C in the pseudocode. And then let's also define a pointer of usize, and this will be I. And then finally, so if we go back to the pseudocode, where is it? If we go back to the pseudocode here, you'll see that both in the recursive version and in the iterative version, the first thing that's returned is whatever order was passed in. So we'll have a Boolean to track that. Now we're gonna define some initialization. And here we just need an allocator and the source list. So the source list is gonna be, let's just call it slice of type T. And then this is gonna return bang self. Okay, very good. And in particular, we want to do a defensive copy because if I use this in the future, I don't want this mutating the list that I pass in. I want this operating on its own internal list. So just be careful not to do this in like a production code base, because if you pass a list in here that's like billions of items long, making a defensive copy is just hyper wasteful. So let's dupe that. And what we need here is So type T, slice. We also need to do a counter, and that's going to be alloc.alloc. We're going to do usize, and we're going to do slice.len here. And then I think, okay, so memset is what next. Memset. So this is the counter, and we're going to set it all to 0. I think now we are safe to return a struct. Okay, so let's set items to items and counter to counter. We want to set the pointer to 0, and we also want the first boolean to equal true. Okay, very cool. Now, since I am going to be probably reusing this, I think, because right now I'm doing a bunch of problems in Zig. I'm on a Zig kick right now. I'm going to have a D-init. I don't think it's required to deinitialize because the OS will clean up the memory on its own at the end. But just for posterity, I want this thing here. And let's do alloc.free on self.items. And then we'll also free the counter. Very cool. And finally, this is the meat and potatoes. So the next function, I need to reference itself here as well, will return a optional list of type T. And it's very important to know how iterators work here. This next function, this next method is going to be called inside a while loop. So we're already inside a loop as we're implementing this thing. This question mark here says it can either return this type, which is a list of whatever generic we pass into it, or it could return a null value. And when a while loop receives a null value from next, it just stops iterating. So that's why, anytime you go to definition, you'll always see it start with a question mark. Just don't get tripped up by it. Okay, so the first thing is the first iteration. Let's go if self.first. First, we're going to just return. Well, first let's set this to false, and then we'll return self.items as is. Now, after that first iteration, we're gonna say, okay, let's do while self.pointer is less than self.items.length. So while it's within bounds of the array, we're going to do something. And the second that pointer goes out of bounds, we know that our iteration is over. So we'll just return null and end the while loop. Awesome. Now, yeah, guys, I'm tired. You should really increase the playback speed. Okay, so now you want to try and compare this pointer to count. So let's very quickly define what count means. Self.counter. And this is going to be whatever the count is at the pointer. And then if count is less than self.pointer, if the count is less than self.pointer, I think that's correct. Why do I keep going this way? Okay, let's just do that. Much better. Okay, very cool. So if the count is less than pointer, yeah, that's correct. Okay, if the count is less than pointer, again, we're going to do something. Now, if it's not less than pointer, we just want to continue with this inner while loop here. And the way we continue, the way this whole thing works is we take the count and we clobber it with 0. And then we increment the pointer to go to the next spot, right? And this is just sort of resetting as we go, resetting the count as we go. Now inside this if statement, if this condition is ever met, this is where we do the swap or rotate. So if we come back here, you'll see that if you scroll down, so here's a log and it's rotating, then it swaps, then it swaps, then it rotates, then it swaps, then it rotates, then it swaps. And even in our image, you can see, so it swaps, rotates, swaps, rotates, and it's always alternating between those two sort of states. So this condition means we found a place to swap. We're going to do that swap, and then we're going to do the opposite of what we did here. So the opposite being, we're going to increment the counter. You're going to increment the count at that pointer position, and then we're going to reset the pointer because we found the swap. We want to restart the process over again with these new values. Okay, and I believe I'm missing one step, and that step is output. I'm going to output it. So it's just return self.items. Self.items. And the swap is pretty straightforward as well. So, we can do if self.pointer is even. We're going to say this is the 0th index, so that's a swap, and otherwise we'll go with count. So this is a swap, this is rotate, and then we can use std mem swap here of type t, and then we'll reference self.items at the pointer, and we'll swap that with whatever j happens to be. Okay, let's see what the error is. Expected, comma, after, yeah, okay. Oh, that was dumb. Okay, so, so this was slightly easier than I was expecting. Let's see if we can, just sort of test this out. We'll test it out on a string. Hold on, let's do const string, and we'll do A, B, C, and D, whatever was in the Wikipedia article. And then we'll initialize the perm iterator for, I guess this would be a U8, and then initialize it with an allocator and the string. And then defer pit.deinit, and then while pit.next, this will give us a permutation. We'll just, for the time being, let's just print everything to standard out. Try w.print and we'll give it the permutation here. Let's see if this even compiles. I have no idea. So perm string found const. Okay, so slice should be const. Okay, that makes perfect sense. Because we're not really modifying that slice, right? Like, we're doing a defensive copy. So let's see if that fixed it. So d init. Oh, right. Pass in an allocator. Okay, so if you happen to be a college student, errors are your friends. Please do not get flustered, right? Like this is telling you exactly what's wrong and exactly how to fix it. You just have to do a little bit of, reasoning about it. So, don't get flustered. This is just part of it. It doesn't matter how big and bad you end up being in your career, you're always going to have errors, and that's a good thing. Okay, awesome. It's building. Well, let's try to run it and see if it produces. Okay, let's take a look. So it looks like the permutations are happening. DDD, CCCC, BBBB. Okay, this looks good to me. Just eyeballing it. I'm satisfied with this. So let's go back into our file here, and I think we can start the solution in earnest. Okay, so let's go back to the problem, and let's see if we can start codifying some of these concepts. So some of these concepts include cities, roads, and then distances. So that's not too bad. Well, distance is the easiest one. So this is just going to be a U size. It's just a number. City. Okay, I'm not sure if this is the most efficient way to do it, but I am going to go with enums here. And in particular, okay, so Faerun, Tristram, Tambi, Faerun, right? Faerun, Tristram, Tambi, I think Norath was one of them. Norath. Let's see. Snowdin, Straylight, Alpha Centauri, and Arbre. Snowdin, Straylight, Alpha Centauri, and Arbre. Very cool. Okay, the next thing is the concept of a road. So a road between two cities, let's just call this a struct, and it's going to have a source and a destination. So the source is going to be a city, destination is also going to be a city, and this looks good to me. Okay, we're also going to need a list of cities, right? Like I defined an enum, but I also need a list. So there is something in the standard library called stdenums.values, and I can call that, but I would prefer just to do this manually for now. Not sure why it was called as numCities. It's just I would be more comfortable with it. We can try and make it a little bit quicker to generate here. And we can call this cities and eliminate that. Yeah, that looks good to me. Okay. Okay, cool. Let's do this numCities. I think I'm going to be doing some parallel array processing, and I want to enforce that the size of this list is exactly 8. Okay, very cool. Well, now that we have those concepts in place, we're safe to do high level. So now let's change this to city. Instead of allocating string, which is no longer exists really, we'll do cities, and then this stays the same. Okay, we also need here, let's get rid of this. We also need a map. This will be a map of roads to distances. Very cool. And we'll just use this throughout to determine the distance of any given road. And we can deinit this, deinit. So auto hash maps do have a reference to an allocator internally as a part of their state. That seems not okay to me. I don't know why it's keeping a reference to an allocator, but I do think Zig, the Zig standard library, is moving more towards unmanaged. So that is a good move. That is a good move. I don't want things to allocate anything. You know what I mean? Without my knowing, like, what are you allocating? How are you allocating it? You know. I mean, you could always go to definition, but I don't want to have to read other people's code. I just, you know, like, I'd like to know when something is being allocated. That's all. Okay, very cool. So now we have to parse the file. And the way we're going to do this is basically, okay, so we're going to use the reader take delimiter inclusive. I'm going to try to speed up here, because I also want to go to sleep. And then we're going to catch the error, and we're going to switch on it. Do I need a semicolon here? I have no idea. I'm going to put a semicolon here. And then we're going to switch on that error. And if it happens to be an end of stream error, we'll break. Otherwise, let's just return that error as though it were a try, right? This is the only error we care about, really. And because we're using take delimiter inclusive, this new line byte is coming with that. So we got to trim that out. So let's do const line trim. These are bytes and line, and we're trimming in particular new line. We don't want that new line in there at all. And then we'll pass all of this to a function. I haven't defined it yet, but we're going to give it our line and a reference to our map. And this function is going to parse this line and populate this map for us. Very cool. As far as, like, once the map is populated, it becomes a lot simpler, right? So we have this thing that keeps track of the minimum distance, and this will start off as the maximum usize, value. And then here, we're gonna have another function called calcdist, which will take that permutation, that list of cities, and a reference to the map that we populated earlier, and then calculate a distance for us. And then we'll just update the minimum distance as we go. This seems to me to be totally reasonable. And then finally, we're going to try to write that distance. I should have macros set up, man. Like, sometimes Zig is unnecessarily hard. Also, maybe it's my IDE. I don't know. It could be a lot of things. Maybe it's not Zig's fault. Okay, so we have this one. This is not going to compile because we need to define a calculate distance, and we need to define parse and fill map. So let's do that. Calculate distance is pretty straightforward. You iterate over that list, construct a road from the elements in that list, pull the distance from the map, and just add it up. So I'm sure you guys can do this part, right? So instead of sort of talking about what I'm typing, I would just like to say it's now public knowledge that that the juicy main is now a part of master branch. So those of you who don't know or have not been keeping track, there is a new signature to the main function in Zig now. So you can have a main function that doesn't take any arguments, but you can now also have a main function that gets a pre-init struct, basically. Let's call this var total. And this pre-init struct has a whole bunch of goodies in it, like things like allocators and IO, like IO implementations, like a default IO implementation, environment variables, like a whole bunch of really cool stuff. And now that does worry me a little bit. I just want to air out those worries here. Kind of shouting into the void. I'm sure nobody really cares here, but I kind of care. The thing that worries me a lot is that it's going to affect how library authors write their function signatures. Like the really nice thing about Zig, the really nice thing about it is you could tell just from a method signature whether something is being allocated or not. And I can make a decision based on my use case or my situation whether I want that for myself. So what I think might happen and what will make the whole ecosystem worse is if library authors started requiring you to pass in the entire init struct, std.process.init struct. Like that would be just absolutely atrocious. Like if you make me give you all of this information and I have no idea what you're going to do with it, I don't know if you're going to allocate or you just want to read an environment variable or what. I'm not using your library, dude. I'm just not going to do it. So I would really like the original convention to remain. I don't know how else to say that. I mean, here's the thing. The nice thing about Zig is that everything is explicit, and it's not just enforced by the language; it's enforced by the culture. Like there's a whole culture around Zig at the moment, where every library that's out there tries to inform you what it's doing based on its API, based on its public API. And I actually really like that. I don't think, well, other languages do it too, but not to the extent that Zig does. And I just want that to continue. That's all I'm trying to say. Okay, so let me explain what's going on here. Get, so map.get can return either it can return a value or it can return a null. For example, if the key doesn't exist in the map, and what I'm saying here with this dot question mark is or else. This is a shorthand for or else unreachable, meaning that if this returns a null, Zig should consider that an error condition and it should panic basically. And I'm comfortable doing that because the input is supposed to be a complete graph. All right, so hopefully that doesn't happen. Like I trust the guys over at Advent of Code to not give me faulty input. Okay, very cool. So calc distance, please increase the playback speed. Like I'm hearing my own voice as I talk, and boy am I slow right now. Expect a return type. Oh, right. I give it a return type. The return type is dist. Okay, very cool. So that takes care of that. Okay, so we did the permutation part of it. We did the high level code. We did the concepts. The only thing left is to parse the file. And the way I'm going to do it is I'm going to try to do parallel array processing here. So I'm going to yank this. I'm going to paste it down here. And so let's see, change till colon. We'll call this prefixes. And we'll do const u8 here. Okay, so let me just explain what's going on. Let's do dash m input dot zig. Okay, input dot. Oh, why did it happen? Input dot txt. So I'm looking at these city names, and I'm seeing that a combination of the first two characters is a unique identifier for that city, right? So we can compare, we can check that the first two characters of each city, and based on that, we'll know exactly which enum to assign the source city to and the destination city to. So that's what I'm doing at the moment. That's my strategy here. And if we come down to wherever I was, enum field missing, name, I'll look at that in a second. The cities were at prefixes. Okay, so let's do a macro. Let's do QA, find dot, replace quote, tilde, delete till comma, insert quote, escape, down, and recording. Okay, so now if I do 7 at or 7 at a, oh man, okay, let's do 7. Okay, what's going on at a? All right, let's try this again. Q 0. One more time, and then I'm just gonna do this manually. Oh, wait a minute. QA. No, hold on. QA. Okay. 0, find dot, replace double quote, tilde, delete till comma, insert this, go down, and recording, and then at a. Okay, that worked. For at. Yeah, that working. Okay, very cool. All right. Okay, so I have these prefixes. Let's define that function, and we're going to blitz through it. Call it parse line and parse and fill map. And here we give it a line, which is basically just a const u8, and then we also give it a map, which is a pointer to a map of road dist, and this is going to be Bangkok. Okay, so what do we need from the line? We need a source city. We'll allocate space for that on the stack. We're going to need a destination city from this line. And we're going to need a distance. Okay, and then eventually we're going to do some line parsing here. And then eventually we will want to create some roads, right? And because this is an undirected graph, we're going to have a forward road and a backward road. This is the forward road. And then I'm going to yank block. railroad, and that's just going to be the destination and the source. And then finally, we're going to put that into our dist map. And forward, and then this will be dist, and then we want the same line. Oh man, I think we can't paste. Okay, very good. So that's the gist of what we're trying to do here. But we have to get that information from the line. And the way we're going to do that, okay, let's look at our input real quick. Okay, so the way we're going to do that is first we are going to split on space to space, and that'll give us this substring and then everything over here onward. Then of these substrings we can check the first two characters, the prefixes, the input prefix, and compare that to our list. And that will help us to determine which enum to assign it to. But then for the second iteration, we also have to split on equals. And the reason is, let me just highlight that. So equals, so once we split on equals, we'll get this string and then whatever comes after the equal. Now the first one we can discard because we've already used it up, but this second one, we'll parse that into our distance. Let's just do that. Let's keep going down here. I have no idea what this is. Faerun. I'll just have to come back to it. Enum field missing. Like I'm gonna need a stack trace for that, man. Enum field missing name? What are you talking about? Okay, we'll come back to it. No big deal. Okay, let's parse the line. We're gonna need first a boolean. This will be true, and this will keep track of whether it's the first iteration or the second. We also want an iterator. We use split sequence for that. And this is going to be of type U8. We're going to do this on the line, and the split is 2. And then we'll do while hit 1 dot next substring 1. Alrighty, what do we want to do here? First, we need the input prefix, and we'll say substring 1 will be, that'll be the first the prefix that the input file is giving us. We also need the endpoint, which will be a pointer to a city, and if first 1, we'll have this be the source city, else we'll have this be the destination city. And then for each of the known prefixes, we'll compare that with the input prefix. So if equals type, I think this is just going to be a U8, type U8 prefix, input prefix, and if that comparison goes through, we know that whatever endpoint it's pointing to should be the value of cities I. So why am I so confident that it's going to be cities I? Well, because we're doing parallel array processing. So faa run, this FA is at the same index as this, and O is at the same index as Norath, and so on and so forth. So because it's a parallel array, this sort of works itself out. Okay, very cool, very cool. Now, for the second iteration, so if first, right? If first, we can just say set first to false, and then continue. And over here, we know we're in the second iteration. And here, we have to do kind of the same thing that we did before. So let's do var first 2 is equal to true, var if2 is equal to split sequence. This time we are doing it on substring 1, and our split is going to be on equal sign, and then while to.next substring 2. We're going to first toss away that first iteration. So if first 2 equals false, and then continue, tossing away that first iteration. And for that second iteration, we're going to say this is equal to try parse int, and this is going to be of type dist. Buffer is going to be substring 2, and then base 10 is how the input's coming to us. And yeah, that should do it, right? That's all of it. Let's look at the full stack trace. Let's try to build and look at the full stack trace, see if we can debug what's going on. Okay. Use of undeclared identifier dist, enum field missing, FAERUN. Huh. Maybe I modified the name. We'll take a look. But let's go to line 195 and fix that typo. So it's 195. And then let's see if we can faa run. Enum field missing name? What the hell is that? I've never seen that before. Huh. I have to Google. Zig enum field missing name. Is an identifier similar to field. Okay, got it. Assign integer values starting from 0. Okay. Oh, is the dot throwing it off? I think the dot's throwing it off. Okay. Dare I do another macro? Okay, let's just do it. QA find dot x down, stop recording. Okay, now if I do at or at a. Okay, let's try this again. QA 0 find dot x down, end recording at a. Okay, there we go. Now we can just do this for all of them. Okay, cool. Let's now try to build it. Okay, parse line this. Oh, okay, right. That's an error unit. Let's go to parse line, parse and fill. Okay, very cool. And just out of curiosity, do we get a number out of this? No, no, we don't. So it hit unreachable, and it hit unreachable because this get road. Okay, so something wrong with our CalcDist implementation. Likely. Oh, it could be something wrong with our parsing because we blitzed through that pretty quick. Let's go here. So our parsing, let's see here. Okay, we have endpoint city. Let's set to that. Then we're iterating over prefixes, equal prefix. It could be this. I don't see why it would be this, but let's just try it for kicks and see what happens. Okay, let's just try it for kicks. Okay, that did not work. Okay, let's start printing what is in this map. Like, what are we putting in this map? Or at least, CalcDist. Let's just review this real quick. If I is the last index, break. Okay. Oh shit. Oh shit. Shit, I'm so dumb. Okay. List. Okay, let's try this again. Yeah, so now we're getting 117. Let's see if that's the correct value. Yeah, so 117 is the correct answer to the first part of the puzzle. Second part of the puzzle is just to show off, Santa decides to take the long route, longest distance. Okay, that's pretty easy. Let's go back here. Let's do %s. %s min dist, we'll rename that to max dist. And then we'll find max dist. And we'll switch over here to min. And then we'll switch this to max. And that should do it. All right, so sig build, and then we'll run it. So we get 909. Let's see if that's the correct answer. Yeah, it's the correct answer. Awesome. So I'm hoping that you guys learned something from this, or at the very least enjoyed the show here. If you want to try this yourself, I recommend you try the slightly more optimal version, which is implement the lexicographical permutation. Again, I don't know if I'm saying that word right. The lex permutation algorithm, and then just iterate over half. So that's your, you know, that's one way to do it. That's pretty approachable. But if you're a psychopath, try implementing this one. Try implementing this one. I bet it'd be pretty fun. So the pseudocode is down here. Okay, very cool. Thank you very much for your time.